Hello everyone, it's me Eric. Welcome back to my channel. Today we're going to try to learn how to implement Yolo V1 from scratch using the Tensorflow framework. So I see many of the people on the internet implementing them, but they don't have a clear explanation of how the architectures work. So today we're going to try to implement a really simple. Alright, so first we're going to import our libraries, and then we're going to try to make a text file that contains all the images path, and all the bounding boxes in one text file. So that we're going to try to read that. Okay. So first we're going to create a converting function, which the input is going to be the folder, the name, and the file. So the path is going to be the folder plus this slashes and plus the name. Then we've got a path. Path is going to be, we don't convert into an OS path, like convert into a path instances in the OS. We've got the tree. Oh, we need to import the tree too, the ET. So from import xml.datatree.element3 ET. Okay. So tree equal to parse, it's the parse path. Root equal to tree. Okay, we got the root of that. Okay, so after we got the root, we're gonna iterate. Oh, first we're gonna write the. So we got a file in here, and that file we're gonna write it. Actually, let me try to do this. So with open os.path.join stimulus. Yeah, so this is where we create a file and we create them as f. And for file in os.list the training. If the files ends with XML, the convert function, folder equal training, equal training file, and file equal F. That's what we want, right? Okay, so yeah, so iterate all the XML file in the annotation folder, and you're converting them. Okay, so now we're gonna write the file. So this is a text file. We're gonna write them. File.write folder plus actually the path folder. Can do the path, but replace XML with PNG. So images in the PNG format. And we iterate all the objects in iterate all the objects in the loops. So like every file we have 1 to 2 bounding boxes, and then we iterate all the boxes in that. Okay. So difficulties equal actually fine. So in the XML file in here, we're gonna see the old POC format. We have the difficult. Yeah. So this can be either 0 or 1, and now we're gonna try to find that. So if the class name is not in the classes num.keys or int difficult equal to 1, then we're gonna continue. Okay. Looks like you don't want to use the difficult equal to 1. The classes num is the dog or the cat classes. So let's say you're gonna make classes num equal to dog for 0, dog 0, and cat is 1. Okay, so this is just a really simple implementation of that. And we're gonna get the bounding box equal to int object find bn box. Okay, have that. Yeah, we have the bn box in here, right? Object find bn box and find xmin. Do text, right? Convert it into text and finally make it into an integer. And we'll just copy that. Copy that and copy that. Right? So we get format a little bit. That's not one. Yeah. Alright, so this one will be running. Sorry. And we got the bounding boxes. We're gonna have the ID, which is the class. And this equal classes num keys. And we find the index of that. So here, the class name, yeah. So it will return, so for example, if it's a cat, right? If it's a cat in here, let's return 1 for the ID. And we just write to the file, right? Write to the file. File.write. So remember, already write the path in here, so we have a space in here, and then we start to join with comma. Okay, so what we're gonna do is like we have a space in here, and then we iterate for all the box. It's gonna be separated by a comma, yeah, and then a comma, the final comma for the ID, for the class, yeah. So file.write. Oh, actually no. After we iterate them, we're gonna do file.write a new line, right? Okay, so let's see if it's working. Actually, we're not have training folder in here is annotation, so folder. So folder the images. Folder the folder. So the image is in the images folder. So where the images are. Let's do that. It's gonna take a while. Oh yeah, once again. Images cat test. Oh, my bad. Is it training in here? Annotation in here? So what I want to do is like I want to move all the images in the images directory into annotation, right? So that's what I want to do for now. So yeah. Because I want, yeah. So usually on the Preprocessing, that's how they make it. They make all the XML file and the images in the same folder. So I'll try to do that one too. So I'll copy all the images to the annotations folder. Alright, so we only have one folder. That's why I do ends with XML here, because it's only a mix of XML file and PNG files. So we got that. Let's see. Oh, it's loading. Okay, yeah, we got that. PNG and then XML. Alright, now let's run that. Let's do this one. Alright, so after we got the text file, we're gonna start reading that text file. So OSPAD, normal, numpad, annotations. New as a read only file, as f train Dataset equal. Let's see. Oh yeah, we have annotation here. So you can see here, mostly this datasets only have one bounding boxes. There may be two somewhere, but yeah, usually it's 1 to 2. Just as very simple datasets. Alright. Now when I read the lines, let's see how much I've done in here. Alright, so so the way I want to splitting them is I want to split them manually. So yeah, so actually let's create a config over here. So I want to have the validation image equal 200 and the train images equal like 1,300 because it's like 3,000 images in here. So I don't want to use all of them. It's going to be very computationally expensive. So yeah, I just want to use both of them. Alright, now we're going to do splitting them, right? So the involved datasets equal train datasets. Yeah, so we're going to take the first 200 and set the remaining. So validation is so let's train. Right, that's what we got. So let's do len train images. Set. No images. Sorry. Oh, sorry. So we got this one. Cool. We use 1,300 images for training, 200 for validating. Okay, now let's see if we actually, let's see, now we're going to try to read that, okay? Class array equal list, classes now, duplicate. So the way I want to do this is, here, I'll show you. And I'm going to have dot cat, not dot equal 0, dot equal. It's not a dictionary anymore, it's coming from the list. So first, if I got this, it should be dot, right? Okay. Alright, now make two functions. Def annotation converting, second here, and def test brings item, image, and the target. So x and y equal this one. Oh, sorry. Just passing that first. So what I want to do is now I'm going to do x train, y train equal annotation converting train datasets. Or dataset, right? Okay, that what we want. And the training, and then training data equal data generator image size, width size. Yeah, that should be it for now. Right, so for annotation converting, this function will take in the train datasets, which is like a lot of path and bounding box convention. So I want to, we want to remove all the new line of the spaces of the delimiters in it, right? Okay, so x equal x and y equal an empty array. And we're iterating all items in a dataset. Item equal item that replace. Yeah, we don't need that anymore. we split them. There it is. X.append item 0. Item 0 is the path, right? And R array equal empty for item range and item. And import the bounding box. Item. Then return X and Y. Okay, let's try to do that. I will show you. Why is that defined? Where is it? Oh, sorry. Alright. So this is what I want. X train gonna be the path, and then Y train 0 gonna be the bounding box. So let's see. X train shape. Oh, sorry. np.array. Yeah, so we have 1,300 path in there, and 1,300 labels in there. Right. So X train 1, Y train 1. That will be that. Alright, next one I'll try to create a data generator. So it's like the different classes that we want to use. This we should leave for later, I think. Let me actually create that first. So I will try to delete this. Alright, let's do a class data generator. So the reason why we do data generator is that we don't, because like if we want to load 1,500 images into our computer and then pushing them to the GPU, it's not taking a lot of RAM. Yeah, so we don't want to do that, right? My laptop right now is only like 8 gigs of RAM, so it's gonna handle that. So I'm gonna use a data generator that can be called every time we fit the data into our model. So that it's not gonna use up a lot of memory anymore. So let's create it. So the data generator is something inherits from the keras into sequence. Okay. So first is init. So images, labels, image size, width size, box size, and class, and batch size. Actually, this is kind of stupid. We can make like a whole config file with that so that we don't need to load it every time we do that again. So yeah, let's just do this up here. Image size, width size, size, okay. Let's copy that. So in here we're gonna do yeah, 224, like 224 images. Width size, let's do a 5 by 5 width size. Box size, wait, the box size when I use 1. So yeah, so like we only need 1 box. That's what I'm saying. It's really simple. We only need 1 box in here. We're gonna try to do 2 boxes like the original paper. Instead of 1 box. So in the class we have 2 classes and a batch size with 128. Okay. Let's run that. I'm going to run this again anymore. Alright, so just let's make this. So self.images equal images. And self.labels equal that len so return np 0. So yeah. By default self.batch size. Yeah, we already have a config file, so batch size, batch type. Great. And then def get item. Yeah, this is the point where I say it's gonna save our RAM a lot because we're not, so like if we have like 8 batches, yeah, batch size is like 128. Yeah, so yeah, so if we have the batch size, it's like 128. So we're gonna try to divide in 1,300 images into this batch size and load all of them to our RAM before it can go to the GPU for training. They're gonna be RAM, and then it's gonna be memory expensive. So the data generator gonna generate 128 images every step in the fit function. So expensive. Alright, so get item. So in order to get item with the batch x equal, so images, idx times batch size to idx plus 1 times the self batch size. Oh my bad. All right, the same thing. Then go for patch y. This one we do labels. Okay. So you're gonna load all of them in here. So images and self labels in here and load in patches. So yeah.